activity. This really goes with the first chapter 1 and chapter 2, first couple chapters of the book. So in this activity, you'll learn to make a mathematical model that describes motion of a rolling bowling ball. And you'll use this model to make some predictions for the time it takes a ball to reach a finish line. And then we'll test our prediction to see how accurate our model actually is. Good, so I'm scrolling down a little bit. The video below shows a ball rolling to the right. Assume that the ball continues rolling past the flag. So let me hit play here just to show you how this works. Now the video doesn't completely go to the ball rolling past it, but you're just to assume that it does. And then you can answer some questions based on this video. So you might wonder what this is. This is your toolbox. And this is a ruler. I clicked on that. You can move that around. You don't need that one for this question per se, but in case you're wondering what that is. Same thing, here's a stopwatch. It's tied to the frame rate here, so I can back this up frame by frame, and you notice the time changes. You can grab the slider here and move it this way as well, all the way back to the beginning. So that's how it works. You can answer the first question based on this. The second part, practice measurements. So go through this one. The demo video shows a bowling ball rolling all the way to the flag. So the first one, it didn't go all the way to the flag. This one it does. So you will use the demo video to learn how to use the measuring tools. And again, to find those, you click this. Whoops. And then you can move these things around. Same thing with the clock. Actually, moving the stick here around is probably more advantageous. It doesn't really matter where you put the clock. Okay, so again, you can go through and answer these questions. There's bold, italics, underline. When you're answering these, make sure you use complete sentences. It usually just asks for a couple of sentences, so make sure that they make sense. You're actually answering the question that's being posed to you. Okay, if you want, you could even insert a picture or bullet points, however you want to do that. Make it look nice. So answer those questions. Part 3, making a model. Select any of the trials that you want to. So to select a trial, you go down here and change it. I would just leave it on trial 1. You might as well. If you want to try some of the other ones, go ahead. And you can hit play. It just rolls part of the way. Just to show you, I'll do trial 2, load. Pretty much the same. Maybe it rolled a little bit farther. Okay, I was just showing you what it looks like. I'm going back to trial 1. Okay, so let's see what else we have in store up here. Select any of the trials. As in part 1, assume the ball continues past the flag. It doesn't literally do that in the video, but we're assuming that it does. Now you'll make some position and time measurements in order to make a model for this. So follow the instructions. It says here, use the stopwatch to measure time. So there's the stopwatch. You can use the straight edge here to measure position. Place the ruler so you can measure the position of the right edge. So I'll leave that up to you to figure out where you want to put that. Okay. And you want to get some data because we're going to put it in this data table here. Whoops, I did this earlier. So let me, I guess I could just use this. So what I did is started 0, 0. At 0 seconds, I'm at position 0. Then I just advanced it a little bit. Let me move the ruler down and show you exactly what I did. Put that sort of on the leading edge. You advance it to a nice convenient spot. Again, you're doing a little bit of estimating here, like where's it actually located. So let's say that is, go another one here. Whatever it looks like to you, 3 centimeters at 0.083 seconds. And then go to another convenient spot. And again, you're doing some estimating here. So this is the data that I got earlier. At 0 seconds, I was at 0 position, 0.0833 at 4. Don't use these numbers. I mean, I don't have my reading glasses on right now, so this could be off by quite a bit. You want to label these things, though. So just click in here. I did time in the first column. What are the units? You always want to have units. I put seconds. What variable am I using? T for time. Position here, measured in centimeters, and then I'm just calling that X. I think it asks for 10 different measurements, so you could click down here, insert row above or below. These don't have to be in sequential order, anything like that. You could go out to 0.15 seconds and then go back to whatever, either way. Okay? So when you first saw this, again, you had to label time, the unit, the variable that you're going to use, position. Call these things whatever you want. This is just what I did. You only had a couple of columns here. I actually added this column, uncertainty in X. And the way I did that was to click here and then insert column to the right. And that gave me this uncertainty in X. Now, what does uncertainty in X mean? When you're trying to measure this actual position, is this at 3 or is it at 4? Or is it at 2? You don't really know. But if you pick 3 plus or minus half of the smallest increment, you can get the uncertainty in X. So for example, if I say this is 3, well, is it 3 or is it a little bit more, a little bit less? By adding a half of a centimeter to my measurement, I'm including the plus or minus part. Actually, this is supposed to be 0.5, so half of a centimeter. So it's half of the smallest unit that we're using to measure these things. And the smallest unit on the measuring device there is a centimeter. So half of a centimeter, 0.5 centimeters. Whoops. Okay, good. So you get to see this in real time, how you can change things around. Okay, so you want to do, make sure you do 10 measurements. I just did 6 to save a little bit of time. And then I inserted this uncertainty column. So let me go back to the instructions up here again. This is all going with this step. Continue measuring, record time, 10 measurements. Okay, we're good on that. Here's the data that I just had. So the nice thing about this Pivot Interactives, it'll create these graphs for you, and this is the graph that I had. So to create this, you actually have to go over here and pick what you want on this column. I'm plotting position versus time as it tells me to. So this is position here. That's what I want on this column. And then the uncertainty associated with the position, I called uncertainty in X. And you can pick whatever you want here, but that's the uncertainty that I have with that one. Okay, done. And then also you have to come here and plot what you want with time. So I'm calling the horizontal axis time, and I'm not including a uncertainty number there. I'm just trusting that the frame rate is correct for this, the time in between frame. There is an uncertainty, but it's a lot smaller than the uncertainty associated with the position, so I just left no uncertainty. In reality, there is an uncertainty with the time, but I'm leaving that one out. I don't have a good way of estimating that one, and I think it's really small compared to position. Okay, so then once you do that, you want to put this actual curve on here. And this is kind of neat. You can go right along this graph and it'll tell you these different values. So to get this line, you click here, curve fits. Now you can see it's a pretty linear situation here. So I picked linear. Curve fits. Let me pick one that is not right, just so you see quadratic. Done. So that's not very good. It's not a quadratic function here. Okay, curve fits. Then I'll go back and do what I think it actually is. Linear. Okay. So it's in point intercept form. Y is equal to mx plus b. That form. So think about back to class what you've done this first week in terms of constant velocity, position, and time. You have an equation for that. Okay, so from class you had something that looks like this. X, we probably called it X final, but I'm just calling it X where we're located now. Velocity times time plus where you began. You might have seen it in this form. this is the same thing. Delta x over t. So this would be like x final minus x initial over time. So if you take this equation and rewrite it, you put it in this form. So really this is x as a function of time. This is really similar to what we just graphed. Remember, we graphed whatever's on the y-axis is equal to mx plus b. And the role of x here, sorry, the role of y here is being played by, whatever's on the horizontal axis. This is what we put as x. The role of x here is being played by time. So you're used to having x on the horizontal axis, y on the vertical axis. But here we put time on the horizontal axis and x here. Okay, so think about this general form, point interslope form, and intercept form, and what we actually have just graphed here. Let's take a look back at our graph. So think about it. I mean, here, this is a point intercept form. So this is what y is. This is what x is, the time. Okay, so you can answer some questions about that. If you notice, there's maybe I wasn't as careful as I could be. This point isn't even on the line. The other ones are pretty close to the line, and you can see the uncertainty associated with the points as well. Okay, and the uncertainty associated with these different values is here. By uncertainty, I mean the plus or minus part. So of the coefficient a, whatever comes in front of here, this is the value, and this is the plus or minus part. Same thing with the intercept here. Okay, good. So again, create that graph, and then there's some questions to answer. Okay. As far as using this program, that's probably the most difficult thing, creating that graph, so hopefully this was helpful. And then there's one more section down here, part 4, testing your prediction. So go through this as well. Read the directions carefully. Insert the same video that you used in part 3. So if you changed it from trial 1 to something else, make sure you do the same thing down here. And then go through this part. And then answer these questions. Make sure you're answering what's being asked, and then when you're finished, you could do save and closed, and that's where it'll be graded. Okay, if you have any questions, send your lab instructor an email, and good luck, and don't hesitate to reach out to us. Thanks.